Good afternoon, everyone. With the immense pleasure and gratitude, today I take the opportunity to moderate this session. This webinar basically designed and developed to introduce you to the some concept of which we'll be discussing during the course afternoon session. There will be a very presiding situation in which we have to go online mode and online learning and teaching online. And today we are having three panelists in this session. In this panelist are the Dr. Nirchan sir from Baba Farid College, Bathinda, India. And the second, that is the international panelist, Dr. Hamid, Islamic Azad University Center, Central Tehran branch, Iran. And other is the Dr. Boyan from the University of Education, Vineba, Ghana. Sir, on the behalf of Baba Farid College, I would like to invite Dr. Manish Goyal, Assistant Director, School of Skill Development from Baba Farid Group of Institution, to welcome this session. And after that, we will brief some of the objectives of this session.
Good afternoon to all. Am I audible to all? Thank you, Dr. Upinder, for giving me an opportunity to welcome all our prestigious panelists from Ghana, Iran, and a number of participants from more than 30 countries, to welcome them on this one-day international webinar on Matlab application in sciences and engineering, which is being prestigiously organized by Baba Farid College, one of its constituent college of Baba Farid Group of Institution. I take it and pride to welcome the panelists and the participants on behalf of Baba Farid Group of Institution, which is a very good step taken by the Department of Mathematics, Baba Farid College, to organize such a webinar in this pandemic situation of COVID-19, which have engulfed all the almost a number of countries where a life as well as the education has been disrupted a lot. Due to this COVID-19, the students as well as teachers are not able to study in their respective institutes. But with the evolve of the technology, now we are able to connect with each other through this technological things, where here we are gathered together and connected across countries as well as states as well as the various universities, where we can interact with each other and exchange knowledge with each other. I am delighted to share with all the participants that more than participants from more than 30 countries, with more than involvement of 26 international universities, more than 26 state and union territories of India, and about 220 Indian universities and colleges. Along with it, I am pleased to tell you all that more than 15 IITs and prestigious IITs and IITs of India, like IIT Roorkee, IIT Ropar, IIT Delhi, IIT Rourkela, the participants, more than 1,700 participants has registered for this webinar. It's an overwhelming response from all the candidates from all over the countries like US, China, Algeria, Australia. I would like to take opportunity, first of all, to welcome our first panelist, Dr. Hamid Dei Kasmai, who is Associate Professor in Islamic Azad University, Central Tehran branch, Iran. Our second panelist is with very vast experience and Associate Professor, Dr. Bonia Ebenezer from Department of Mathematics, University of Education, Vineba, Ghana. And our third panelist, Professor Dr. Meher Chand from Department of Mathematics, Baba Farid College, India. I welcome all the panelists for this webinar and all the participants who have registered with this webinar, as well as who are attending this webinar on this day. These kinds of webinars definitely going to advantage all the participants who are attending this to listen to the latest technological things on today's topic, Matlab application in science and engineering from the panelists. These kinds of things are very, very important, especially in this time where we are locked down in our homes. So these skills are very, very important, and we at Baba Farid Group of Institution, as we have Baba Farid School of Skill Development, we are continuously making such kind of an effort so that the skills as well as the additional knowledge can be imparted to the students as well as the teachers also. So through School of Skill Development, we have the tie-up with all the top associations of India like FICCI, CII, ASSOCHAM, and a number of MOUs with the industry tie-up where we can send our students for internship for the enhancement of their skills. So these kinds of initiatives we are constantly taking at Baba Farid Group of Institution, not only at the national level, but at the international level also, where we have the tie-up with various international universities also. So I once again, not taking much of the time, I once again welcome Dr. Hamid Kasbai from Iran, Dr. Bonia Beznizar from Ghana, and Dr. Meher Chand, and all the participants who are attending this webinar from Baba Farid Group of Institution. A very, very warm welcome to all, and I hope that all the attendees and participants will take the maximum benefit of this session. Thank you.
Thank you, sir. So now I am briefing some of the objectives of this webinar. The webinar provides the gentle introduction to the Matlab computing environment and is intended for the beginning users and looking for a review. The main objectives of this webinar is to cover the understanding the Matlab environment, and after attending this webinar, you will be able to complete simple calculations using Matlab. You will be able to carry out some numerical computation analysis and graphics using Matlab, and you are also establish a family relation with the Matlab to solve other problems and their solutions as a beginner and a researcher. Now I handed over to Dr. Merchant, sir. Dr. Merchant, sir.
Yes, ma'am, I'm listening, and thank you
sir, before
very much.
I will like to brief introduction about the Dr. Merchant, sir. Merchant, sir is a working as an associate professor in the Department of Mathematics, Baba Farid College, Bathinda. His research interest is in integral transformations, special functions, integral equations, fractional calculus, and its application. He has a huge experience in the research field. He has also done some of the research in the areas of cryptography and image processing. He has published numerous research articles in the reputed journals, national and international level. He also reviewed various research articles, and presently he supervises various PhD scholars also. Now I handed over, without taking much time, I handed over to the Dr. Merchant, sir, to continue this session.
Thank you very much, ma'am, and welcome to everyone around the participant. Welcome in the family of Matlab, and hope we will exchange our ideas, and these ideas will be very helpful in our research and other areas. Okay, and Matlab has become an indispensable tool for researchers, scientists, and various areas of industries, academia. So without loss of time, I would like to start from the basic of Matlab. So you can see this is the window of Matlab. So as you can see that in this window, there are 3 or 4 partitions. First, you can see at this place, this is the current folder, and this second part is command window, and the third partition is you can see at this place command history, and this is the part of workspace. And all these partitions play very important role to understand the MATLAB. So the basic commands which we execute can be entered at this place in the command window. And in the current folder, we can save our files in the current folder, which we can work and we can use in the future also. And in the command history, when we execute at this place, other command will be in the history and we can use in future anytime. And all the commands will be saved at this place. And at the workplace, the variables or outputs will be at this workplace. Okay, so I start from very zero level, as you can see. So this is the CLC. By using the CLC, we can clear the command window and then enter. You can see the command window is very clear. So first, the important thing is we need not declare here any kind of variable or parameters which we are going to input at this place. So I will start from very simple calculation part, and this MATLAB play is an important role like calculations. So as you can see at this place, I have a equal to 5, and then a is equal to 5, and when I enter, this is the output. And in the right hand side in the workspace, you can see the value of a is at this place. Variable is entered a, and the corresponding value of this variable you can see in the workspace at this place, that is 5, which value I enter at this place. And again, if I take b is equal to 7, okay, and when I enter the second variable, you can see in the workspace. And also you can see that all these will be in the command history. You can see at this place, this is a equal to 5 and this is b equal to 7, and all these inputs will be always in the command history. Okay, and these variables and corresponding values will be in the workspace. These are the values 5 and 7, and I select here 2 parameters and corresponding their values are 5 and 7. So if you want to add this variable, this is a simple process. C is equal to a plus b, and when you enter, this will give us the output. So now you can see that a plus b is equal to 12, and the corresponding all the values which I enter here in the workspace. And also you can see the third input, which is c equal to a plus b. So all the commands which I will execute in the command window will be saved automatically in the command history, and the output of this will be in the workspace. So at this place, there are some basic commands which are very useful. If I use here clear a, then this command will remove the variable a from the command workspace. When I enter, you can see that variable a is absent in the workspace. And when I use here clear all, you can see that, sorry, so by using clear all the values from or the variables has been removed from the workspace, but this will exist in the command history. This will never remove. This will always will be there. Okay, so these are the basic inputs which we can use. And for multiplication, I can use d is equal to a star b. This will give us the product of these two input. A star b, and enter. Okay, we have to assign the value because the input which I assign here, all the values are removed from the workspace. You can see workspace, the values are not here. So this will not give us output because this shows the error. We should have the values and parameters at this place. So I am using here CLC. This will clear the command window, and again I have to start A is equal to 5, B is equal to 4, and C is equal to, I have A star B. So now this will give us the product of these two parameters. You can see C is equal to 20. In the previous input, this shows the error because I used the clear all and all the variables at the workspace were absent. So it shows error. So in this way, we have to understand why the error shows there and how we can control the command windows, how we can use the workspace, and what is the importance of command history. Okay, so if you all the calculation are used at this place by using in the same way. So if I use select here any kind of array CLC, x is equal to, I have 0, 1, and 10. So when I enter this one, you can see that this x array is from 0 to 10, and the difference is 1 at space. And if I use this one is another way, y is equal to, I use here 0, then I choose here the difference is 4 and 20. And when I enter this one, you can see that the arrow is generated and the difference is 4. And similarly, if I use here, you can take z is equal to, I have one another, and here I enter is 100, and then double dot and minus, I use here 10 and then 0. And you can see that the numbers are in the decreasing order and the difference is 10. Okay, so in this way we can choose the we can select the arrays, and these are very important, and we can take the output corresponding to this one. So if there are so many functions which are inbuilt, see that this is the trigonometric function I am using here. This is z1 is equal to, and this is the x variable I put here. Okay, and when I enter, this will give us the all the values of x array. Okay, and these are the corresponding values. And also this is very important that when we give any kind of command in the MATLAB, this will always generate a matrix. And we can see here at this place, come at the workspace, when I click this one, okay, this will be, you can see that all the variables are in the Excel form. Okay, and similarly you can see this one, these are the values corresponding which I give the input of the Z1. Okay, so all the inputs will generate a matrix. So this name is very famous due to this, because the MATLAB operate only matrices, and on the behalf of this one, the name of this software is Matrix Laboratory and known as MATLAB software. Okay, so in this way we can check all the values. Now I explain one important thing. I am using here CLC. I am using here clear, and when you use this clear or clear all, this will clear the workspace. You can see workspace is clear now. Okay, now I will take x is equal to 0 double dot 0 0.01, and then I have 5, and this semicolon always control the commands. So when I enter this one, and you can see that there is the value is assigned there, and corresponding the value, you can see that x is equal to, we have 1 by 501 columns are there. Okay, these are the values corresponding to this one. If I use y is equal to here sin x, and when I enter, So these are the corresponding values, and we can see this output in at this place. So these are the values of corresponding to these entries. If sometimes we need to generate a table or array, okay, so this can be generated as by using x is equal to I am using in another way. This is 0, and difference I will take here 0.5, and then I have at this place 10, okay, and then I will use here this sign, and then I use here control statement, that is semicolon. This will control the statement, okay, and then I enter. I take here y is equal to sine x. Then I will take one more function y1. This is cos x, and semicolon. Sorry, this is okay. Y1 is equal to cos x. So at this place I have three y and y1, two functions and one variable. Okay, so when I enter, you can see at this place one x is input, then I have y function, and then I have y1 function. Okay, so this is y1. When I enter this one, you can see that the very smart table has been generated at this place. This is the first is x input, and second column shows y function, and the third column shows at this place y1 function. And if you can visit that this answer, we checking the workspace at this place. I will click at this place, double click, and when we click this one, you can see that very smart Excel file has been generated, and all the first column is here x input, and second column is here y function, and the third column here is y1 function. Okay, so in this way we can use these inputs. So this is the arrays and inputs and how we can use. Now we are going to move ahead. First I need to clear this space CLC. Then I use here clear all. Okay, the workspace is now clear. Now we discuss here a format to display. So the format to display play a very important role. So when I use this format short, what will this do here? You can see I use here a format short. Okay, and this will fix the value for 4 decimal digit, and where I take here the input is 351/7, so it will choose only 4 decimal places digit, you can see here. And if I use other format, you can see at its place is format long. So when I use here format long, okay, and I enter, and using the value at this place, the same value I will enter here, and you can see the size of format, and you can see that by using format long, 14 digit will be there after the decimal. These are 14 digit at this place. So according to our choice, we can use this format to selecting the decimal places. And there are some more format you can see at this place. Format short is there. Okay, so when I use format short, and you can see that when I use the format short, this will give us the scientific value 4 decimal digit, and this is the output of this input 357/7, and this is the output, and this will choose 4 decimal places. Okay, so in this way there are so many different formats and we can use, and you can see this format G. This is also very best format at this place. You can see. So at this place I use here format short G. I highlight here, and when I use this one, this will select the best 5 digit of the floating points, and the output input is 351 by 7, and you can see that there are only 5 digit at this place. So this will select only 5 best digit by using this format. So the we can use in the calculation or by selecting the database for our any kind of analysis. We need the format for the input and corresponding the value of outputs. So these are the some styles, and there are some more, but due to lack of time, I will shortly present here. I am again using the CLC. CLC will the clear desktop, okay? And when I use clear, this will clear the workspace, okay? And as you can see that the values which I enter here at this place, you can say at this place in the command history. So I use this value, all the inputs are at this place and stored here, and you can use in future in any time, and this will be available in future whenever you have the this current MATLAB software. So whenever you will not change, these all will be available, and you can use. So I installed this software by today, and all these commands are used today, and these are available with the date also is there, okay? And some time is also mentioned there. So this is the command history, and with the time all the commands will be saved at this place. So these are the role of the command window and the command history. I think you understand the importance of command history, and also you understand the importance of workspace, because whenever the variable which you enter and you want to examine these inputs, the input should be in the workspace, and if the variable is not in the workspace, then this will show the error, okay? So come to the next level. Here is who and whose, okay? Again, I am give some input. I'm using the input this one, okay? And so what is the importance of the command who? Okay, I use here command who, and when I enter, this will show the how many variables are there in the workspace, okay? So you can see that 2 variables are there, and by using this command you can check how many variables are in the workspace, and how many variables you can use in the command window, and these are available in the workspace. And there is one more command, whose, okay? When I enter this command, this will give us a detail about the variables which are in the workspace. You can see that here is variable A and B, 2 variable are there, and this shows the size of the variable, because the input you can see that is only 1, okay? And this is the 1 by 1 order matrix there, okay? Similarly, B is also 1 by 1 order matrix, and these are the bytes and classes and attributes. You can see that the corresponding attribute of this input are not there, okay? So these are the importance of who and whose. We can use to check the variables and their size and information about the variable which are exist in the workspace. I am again using CLC, okay, and clear all, okay? So workspace is now empty. Now we are coming out at the next level. So there are some basic mathematical elementary functions, and we discuss about this, and these are very useful for the statistical analysis, for any kind of data you which one you want to interpret, and these are very helpful to generate your code for coding and programming. So inbuilt functions and how we can use, and what are their code to use this one. Okay, so if you want to take the square root of any value, SQRAT will be used. So you can see at this place to to take square root of any number, we can use this function. sqrt is there, and by using this function we can take square root of any variable or any input. Okay, so when I enter, this give is the output. So it is also very important to know that, as you can say, when I give the input, there is only answer. And if I give this input in this way, z is equal to, I have square root, and then I use a semicolon. And when I enter, this will this semicolon is control the statement or the input. Okay, so this semicolon is very important to create the programming or to use for the to generate the coding everywhere. Okay, so semicolon is used to control the statement. As you can see that the z is equal to sqrt is the input, but this is also shows in the workspace, but there is no output. So when I will take z and then I will enter, so this will give us the value. So at this place now you can see that here is z equal to 1.4142, and in the previous case you can see that at this place answer. Okay, so when we do not assign any value or any variable, then this will always give the output as answer. And if you use this one like assign a function or variable like in this way, then this will always give the value of the corresponding variable. Okay, so in this way we can use these functions. So you can check the other function. Here is sine pi by 3. Okay, this is the sine pi upon 3. So pi is very familiar, and exponential function is very familiar, and we can use directly. So sine pi upon 3, the value will be corresponding. This one is 0.86603. You can check it. And if we check the value of pi, pi, and this will give the value of pi, and you can see that this is the value of pi. And similarly, we can check the value of e, exponential function. Sorry. Okay, and now here is exponential function 1. This is the value of exponential function e. Okay, and there is 1, and you can check that this is the value of e by using in this way. Okay, you can see at this place that log 10 and base log base 10 and value is 15. The variable is 15, and you can see the this is the value. And if I use the in this way, x is equal to 1 to 10. Okay, and this is the control. Sorry, x is equal to 1 to, and this is the control, enter. And when I use this one, and at this place I have x. Okay, so when I enter this one, so all the values corresponding to this x is equal to this input, you can see all the values. And this way we can use the inbuilt functions. This is also very important to know that help function is there, CLC. So by using this help function, all the inbuilt functions, this will help how the functions we can use. So when I enter, you can see here all the functions, the detail of all the functions which are in the Matlab available, and we can use it according to our choice. So at the top you can see that sine is there. Then there is sine d. Sine d is the will give the value of in degree form, and this function sine will give us in radian. here is you can see this is the entry, okay, and this is the one array, and we can choose one more array at this place.
Dear Professor, the page is not seen.
Hello, Professor. My desktop is shared with you. I think it is okay. This is okay. And then after we have, hello, Professor, all the things are okay? R plus T, I choose here two arrays, one is R and other is T. So when I enter this one and S is equal to this one, give us the sum of these two arrays. Okay, so I have less time and we will discuss here some plots at this place, and the plots are very easy to discuss here. We can see okay. At this place, we can see that T is equal to this is the input, and plot 3 is used to display the plot of these parameter. One is X variable. This is the X input, and this is the Y input in parametric form. And when we execute this one by from this place, you can see that this is a very beautiful graph of the input. We have the function in parametric form. One is X is equal to sin t and Y is equal to cos t, and the range is also assigned there. And if you want to change in this place, you can modify according to your choice. You have to go in the figure of properties, and then after you can see at this place I make it in full size, and by choosing this one you can select its position in any direction. And if you want to make more changes, you at this place you can assign the name of this graph, okay, and you can assign the variables and other more properties are there, okay. And there is this is the one more example. You can see that here is function is f equal to, we have this function, and very simple function. This is a trigonometric function used, and in the form of fraction, okay. And this function is used here. Ez surface function is used by a very simple command at this place, and you can use here any kind of function involving two variable, okay. And this will give us a very beautiful graph by using Ez surface, and you can see that surface of this will be generated at this place. And this Ez surface, you can see that on the top, this is the title of the function which is used at this place, and the surface of the function is generated in 3D, and the contours are also there in the XY plane. The bottom is XY plane, and the surface in space is generated at this place. Okay, so there are very simple functions which we can use to trust. This is another one more function. You can see that T range is there from pi 0.3 to pi 60 up to 20 into pi. Okay, and the simple function is used to plot 3 is also we can use it to plot. This is the T is input. This is the second variable, and this is the third one. And then you can see that all the three functions will be plotted in this place. The very beautiful graph at this place you can see. And if you modify, or you can check it in any position by using figure property. You have to visit there and you can change its position and locations, and any kind of rotation you can rotate in at any angle. Okay, you can see this is the 2D, and now when you move in upward direction, this will represent in 3D. Okay, so these simple functions can be used for 2D and 3D. This is very quite simple. I can show you one more example. At this place, you can say, okay, at this place you can see that this is the mesh grid is used at this place, and this is the z function of exponential function is there. And plot 3, this function, this command is used at this place. Plot 3 is very simple function, and you can see that x variable is there, y variable is there, and z is the function. X and y are the input, and the z function depend upon this x variable and y variable. X and y variable are assigned at this place in the form of mesh grid. And when we run this one, this will give us a very beautiful graph you can see at this place. Okay, so there are some more options like animations you can generate also. I gave you one example. Okay, see this one. Animations can be easily generated here. You can see this one. Very beautiful animation is generated here, and you can see that this is the Pythagorean theorem and the circle, and all the points are moving on the surface of a circumference, and at each point this will always generate a right angle when this around the circumference of this circle. So by using the animation, we can use everywhere this command function, but the detail I cannot present here how we can use. But to understand this type of code, the basic concept should be necessary. So I will give you one more example at this place. You can see this is the compass, okay, and contour. Okay, you can see that at this place contour is there, and here we can say x, y are to input, and this is the z equal to function in the complex variable form. Okay, this is the x variable and this is the y variable, and in the form of a complex variable. And I here use very simple function. This is the very simple function. Okay, f equal to, I have z raised to power 4 minus 1, and dot its power is 1 by 4. This is very simple function, and these other are the this will generate the surface of function. And these are other things how we can insert the label, x label, y label, z label. Okay, and when I execute these commands, and these commands are very simple to create here. Okay, so you can see that when I generate execute this command, so you can see the contour graph is there. You can see at this place, and other we have this is the graph of the function. So at this place you can see contours are separate, and the graph of function in 3D is on the other places. And if you can see the that at this place, this is the imagery part, and on the other side we have real part, and the upward which is on the z-axis. These are the absolute values of all the z variable. Okay, so when we take the absolute values, this will represent a graph in space, and the z function, z variable is very simple, like x plus iota y. Okay, and we take a very simple function, and when we plot this one, so you can see the very beautiful graph, and these functions and the inputs are very simple to present this one, and we can use for any kind of data or data interpretation. And there is a help desk. I will close by introducing you the help desk. This is very important because the time is very short and many things are there to present. but due to lack of time, I cannot present here all the things. I will introduce the help. Okay, so at this place you can see that from this place you can take any kind of help which for any kind of data analysis, any kind of function, for derivative, for integration, for to find out the solution of differential equations, and many more. All the things are available in this MATLAB. So you can see that I am choosing here integral. Okay, I will introduce here only one part, and when I enter, you can see that. Sorry, what is there? Okay. So all the functions are available in this part, and when I select this integral transform, okay, so at this place you can see the integral transforms and their corresponding. This is the Fourier, and okay, and codes are also there. You can select here from the mutable is there, and okay, integration. So these are the examples of integrations. This is the integration. Okay, so you can see that this is the command and is used at this place to find out integration, and this is the output. So this help desk will help you at any time, each type of prompts. Okay, so if you want to take vector analysis, you can select here. There are many kind of help. You can see curl, okay, partial derivative, and curl vector is there. Okay, and there are many examples are present there with code are there. Okay, you can check here gradient, and this is the linear algebra. All the functions are here. You can see arrays, examples of arrays which I present here. Their syntax are there, and corresponding example you can see here how you can use these arrays. Okay, you can select, and these are the outputs are also there. So you can choose any kind of help from this place. This is a matrix, and I will give you matrix analysis. Okay, this is the same thing, and this is the limit. We always compute the limit, left limit and right limit. Very beautiful examples are there, and you can use any kind of function. You can see that plot tangent x, and the limit at this place you can see that this is the limit of x variable minus pi to pi, and the corresponding graph you can see at this place. Okay, so all the things and functions are available there, and corresponding to the help desk is very important, and from the help desk you can select any kind of help for your use. And I think time is there 3:08, and I for the next session I have to close this my talk, and in future you can contact us anytime, because in the very short time all the things to present here are very tough. To understand this MATLAB and all the things to display here, we need at least 1 week, and we have only 3 hours to present these things. So that the concept which I present here, these will be helpful for you for the next coming 2 sessions. And thank you very much for this attending my lecture. Now Dr. Upinder will attend this one. Please, Dr. Upinder, close this one. My discussion is over.
Thank you, sir. Thank you, sir, for your knowledgeable and wonderful session. I hope all the participants enjoyed it a lot. Now, the next session, our panelist will be Dr. Hamid. I will give brief introduction of our next panelist. Dr. Hamid is the professor in the Department of Applied Mathematics, Islamic Azad University, Central Tehran branch, Iran. And he has a multidisciplinary research approach in the various fields like quantum physics, computer science, blockchain, quantum cryptography, medicine, engineering fields, laser fusion, solar lenses as new renewable energies, plasma, tokamak, laser ablation, and so on. He is also the member of IEEE, Mendeley, and the ResearchGate, and many more. He is also acted as the editor for the various journals, editor of a Journal of American Academic Research, San Francisco, USA, editor and reviewer of Science Alert Journal, editor and reviewer of EPH Journal, editor and reviewer of International Journal of Innovation System and Software Engineering, and he is also as an invited professor for the number of conferences, and he has near about 40 plus research articles will published in the national and international level, and we are having a very huge and renowned personality in the area of mathematics, and he is also doing the multiple jobs, and he is acting as a HR executive and leader of technical and researcher team at the Hamid Electronic Jahan, and he is also act as a researcher in the Roshanarg Sahar Counting Company, and at present he is also act as a senior lecturer and teacher at the Islamic Azad University. So various fields we have covered under this, and I hope the session will be very fruitful and very knowledgeable session. And in the very few minutes, I request Dr. Hamid to join the session and facilitate our participants. So now I would like to call Dr. Hamid and handed over the session to Dr. Hamid, and I request all the participants to wait for a while so that the Dr. Hamid can join the session and facilitate us in a short while. Thank you all of you.
Model. After this definition, we will go about to some simple examples that can be modeled in Cyber Matlab. One of them that we cover in this presentation is about lift on aircraft wing modeling, in which that you will see the circulation of fuel in the wing, and we will talk about this. And another problem is about the electricity load, about the powerhouses, and many other things that we can see in Matlab. And we use to optimize the performance of parameters that we can call it optimizing, or it can be minimizing or maximizing, and it will be used more in operation research and DEA about optimizing function, or about the problems of finite element method, especially about the Galerkin method, or when we want to optimize the residual function when it tends to 0. And we want to find the approximate function that is really close to exact function. So we have it. Okay. Another application about here, there are first principle modeling and data driven modeling. modeling. So what are them? In fact, what we are saying about them? Let me see what happens about it. Okay, what is first principle modeling that we have talked about them as a first. So some applications of using first principle modeling is about using experimental data instead of statistical methods to estimate model parameters. And this is one of them, and it can be used based on the interpolation and extrapolation by data-driven models. It can be used for those problems too. But about this problem, we have two things that is required: cost and the time and skill required to develop an application, a specific model to present large advances on convolutional empirical modeling with many packages or programming code environments. So one of them is, as an example, about pharmacology. Pharmaceutical companies are using fungal bacterial and mammalian cell behavior model to support process and control studies. Okay, it needs the field research for modeling in industry, so it will be very hard to uh, and Georgi Macmillan ISA. Now we will go to consider about these both kind of the modeling. The first one in this arrow, accurate requires plant and requires data acquisition system, and about the DDM insight in behavior physical parameters. They have very good to use, but disadvantages is this very time consuming process and requires expertise.
ਹੈਲੋ ਸਰ, ਉਹਨਾਂ ਨੂੰ ਨਾ ਜੁਆਇਨ ਕਰਨ 'ਚ ਦਿੱਕਤ ਆ ਰਹੀ ਹੈ। ਇੱਕ ਬੋਇਨ ਸਰ ਜਿਹੜੇ ਹੈ, ਮੈਂ ਕਾਲ ਕਰ ਰਹੀ ਹਾਂ, ਸ਼ਾਇਦ ਹੁਣ ਜੁਆਇਨ ਕਰ ਗਏ, ਇੱਕ ਵਾਰ ਚੈੱਕ ਕਰ ਲਓ। ਹਾਂਜੀ ਹਾਂਜੀ ਠੀਕ।
Hello.
Hello, Professor. I am Dr. Lear here. You can start your talk now. Yes, you can start.
Okay.
Yeah,
Thank
good
you
luck.
very much.
Yes, good luck. You can start.
This opportunity. Okay, thank you very much, Winiba. I want to start the presentation by sharing with you a brief
Yes, it is visible, and
Can
your voice. Yes, your voice is also audible to me, and all the audience. Yeah, good luck. You can start.
Yeah, I'm starting my presentation by just giving a brief perspective of Matlab. You see that Matlab has become an indispensable tool in analyzing non-linear scientific problems. And of course, you all share with me that modern science requires comprehensive and robust scientific to enable one to analyze numerically a given problem. I'm also saying that Matlab has a very good picture of pictorial quality than other known software. It has a wonderful numerical inbuilt function than other software that are common to us. Now, I just want to quickly look at very basic application, which normally occur even at the senior high school. I want to call a volume of a right circular cone, of radius r and a height h, which is given by v is equal to 1/3 pi r square h. We want to see how we can plot this in a Matlab environment. Given a range, radius which span from 0 to 4, then the height, the interval span from 0 to 6. So this can be plotted in Matlab, and we can obtain a 3D dimension of the picture or figure that have been displayed now. And this tells you how wonderful, even at the senior high school level, you can introduce students the usage of. You don't need to introduce students Matlab at the university level. Even what they do at the senior high school, Matlab can be embedded in the curriculum. This is another application, electrical engineering problem. Here I'm saying that electrical circuit below, the applied voltage Vs was kept constant, and then the voltage Vc across the capacitor was measured and recorded at several frequencies as shown in the next slide. Usually in the lab, these are some of the things we want engineers to do. And I'm showing you a diagram of the electrical circuit and the respective measures of change in the experiment, capacitor voltage versus radiant frequencies. And this can be numerically plotted Matlab as shown now. The VC in voltage, the vertical axis against W in radians seconds. This can easily be interpreted using the diagram, and it makes easier an engineer or beginner to understand or appreciate the problem being studied. Now, I'll move quickly to ordinary differential equation, which cut across almost all the engineering discipline. It will be chemical engineer, material engineering, mechanical engineer, electrical engineer, all requires sometimes some amount of knowledge in differential equation. This typical differential equation with the associated initial condition that can be analyzed. Of course, people have some perception that Matlab is used for numerical analysis. However, in some occasions, Matlab can be used in dealing with analytical solution. if the problem is all too non-linear. It can be used. So having solved this, these results numerically analyzed in Matlab, and this is the graph shown. And of course, this is a phase portrait solution which can easily be understood if a then or an engineer understand basic graph or basic principle in plotting, or linear graph, nonlinear graph in other disciplines like mathematics. You should be able to do this. I also try to embed another interesting application in what you call fractional calculus. Modern science is telling us that knowing what has happened before, that the history and the present will always help us to predict better in future. This model is a simple tuberculosis model formulated by myself some time ago, where the S is a susceptible latent population in infected population in treatment. Here we employ what you call Capito-Fabrizio operator. We analyze this analytically. Then we move on to solve our problem in Matlab using Matlab. Here, I must emphasize that it requires a bit of coding. We coded using algorithm of Capito-Fabrizio, coded Matlab, and we obtained very wonderful solution with a very good graph, which I'm going to show you in the next slide. These are the graphs obtained. And you can bear with me that these graphs are very sharp, very neat, very nice. Very nice. These have been plotted with different fractional order, derivative order values. Of course, those who are interested later, you can send me email. We can discuss further. Maybe we could do some other work. But I just try to show to the scientific community that Matlab does very wonderful things as far as sciences are concerned and engineering. All these are values, different of the fractional order. Hello? Can you hear me?
Yes, Professor, we are hearing you and your voice is audible and we can see your PPT also. All the things are okay. Good. Yeah, carry on.
That's good.
Yes, yes, good. Thank you. Now, thank you, carry on.
Now, in recent times, we try to look at obesity. Obesity has become a global problem, most especially in the developed country. We model obesity in the context of what you call fractal fractional order in ABC, what you call a Tangana Verano derivative. So here I usually tell them as double operator. In my country, there's an adage which says that two heads are always better than one. Of course, if you use one operator, it's good. But if you are using double operator, for me, it's better. So this is a typical obesity model, which studied, and through the help of Matlab, we're able to numerically solve this problem, fractal fractional order in a Tangana derivative. And let's see what we had. We had a very wonderful result where at one time we kept one of the operators constants, alpha constant. Then the other operator were manipulated to see the kind of dynamics that we're going to have. So that's what we do. Another instance too, ladies and gentlemen, we also this time kept the other operator constants. Yeah, we kept the other operator constant, the other operator constant, and alpha were buried. In another instance, too, alpha was kept constant, other operator was also buried. So we want to see the dynamics, whether each operator has different effects with respect to the dynamics associated parameters, of course, with their respective initial condition. Then also try to basically look at something interesting here. This is ordinary differential equation in the third order, which of course we all know that this can be converted into first order differential equation. I believe everybody knows how this can be done if you have done a bit of mathematics. So we say that you can write a very basic MATLAB course. So I want to share this with you. Try most of the time, let your students play with this simple course. It will increase their confidence. It will help them to have a flair with the MATLAB as a software, and they can do wonders. So of course, this simple problem can be coded as shown here. Then when it's run, take this graph. Of course, this is very nice graph where students can easily be taken through to understand, and this look more or less like a student will understand this better than sometimes just analytical solution. And that is not all. I also try to share another interesting which Allah have not applied. In this have been published in very renowned journal in China. Some of you are interested can check this paper, this model. It is an economic model for other economic model, which we try to use different operators. We use Atangana, we use Fabrizio, we use Capito, leverage operator. Then we wanted to compare the variety of this operator. And I want to share with you some of the results obtained. You see that with the help of MATLAB, we obtained these wonderful graphs where we actually interpreted them in the light of the model which had already been done before. We will compare our result with the existing result, and you observe that we had better result than the previous work people did, same model. Now I want to say thank you and end my presentation.
Hello, Professor. Are you there?
Yeah.
Yeah. Professor, please let us know about the importance of mathematical modeling in our daily life or in other branches of sciences, and how can we use this modeling to find out solution of various problems in around the world.
Can you come again? I couldn't hear you better.
Yes, I want to know the importance of mathematical modeling to find out the solution of various problems like virus or just now we are facing COVID-19, and I know that this very useful in this area also to find out the solution. So please explain the importance of mathematical modeling briefly.
Yeah, mathematical modeling. What is mathematical modeling? What we are trying to say basically is that you want to mimic reality. You want to mimic reality. Of course, in an absence of data, modeling is the substitute. If you take a look at the COVID pandemic, which is killing the whole world, economic, whatever, having on us. Matlab modeling will help you, for example, to understand various scenario strategies that can be used, for example, to unlock. How do you unlock a given country if you lock down a country? What are the strategies and what are the consequences? Matlab can help you to get this perspective, and it's up to you based on the etiology of the particular disease to help you to decide which perspective to go. And I can assure you, for example, you calculate reproductive number of a particular. Sometimes you need this MATLAB to incorporate the actual parameter values to determine the threshold in terms of numerical value, whether maybe the strategy that you are putting in place to reduce the spread of the COVID, whether it is working or not. We need all these things. So I recommend that in every serious country or nation, it is important to have what you call research or infectious disease modeling center, where you can co-opt people from the academic side who are experts in modeling to be part of those who do what you call the life sciences, who do not have much knowledge about the computational aspect of disease dynamics. And I'm saying that where I'm coming from in Africa, due to poverty, resources, and so on and so forth, it is very difficult to have such systems. However, we are trying our best, and I can say that you can never do away with modeling in any setting. If you want to, for example, go into oil production, you cannot just straight away go and model, go and extract oil. It will not work. You need to model the geology pattern that I have observed in the lab. And this comes with PDE's equations. And what do you need to solve? You need numerical solution. These require MATLAB. So for me, MATLAB as useful as human being as also equally useful as MATLAB. We cannot do away with MATLAB, neither MATLAB can do away with us. It should be part and parcel of everything we do in everyday life.
Yes, Professor, there is a last question from the audience. They are asking about good references for mathematical modeling.
Yeah, mathematical modeling.
Yeah.
Mathematical modeling, as I said, it is a strategy, or it is a discipline of mathematics that requires several, sub-disciplines in mathematics in order to develop a very good model. For example, to do a model, first of all, you must understand what we call the etiology of what we are trying to model, or the principles or the dynamics of what you are going to model. That's very, very important. That is going to help you to formulate the right assumptions. Of course, every model are based on assumptions. If the assumptions are wrong, the model are also wrong, right? So once you get all this right, then depend on what you want. Do you want to have your model in PDEs, ODEs, fractional, whatever system you want to have? Then you proceed in that context, right? But we live in a scientific community, and every day people are doing research. It has been established that fractional derivative or the fractional integral present or give better results. So modern sciences are saying that most models or modeling that have already been done, people are even trying to reconfigure or reformulate them in fractional perspective. And for me, once you have a command in coding in MATLAB, there's nothing that you cannot model. You can model anything that exists on this globe. So in other words, in simple terms, you must fluent in the subject matter, as well as you must also have a command in coding in MATLAB. These two things come and go hand in hand. That's what I can say.
Please give me some good books references.
I should give you what?
Good references for books and your papers for the audience. they are asking about good books to start their career in mathematical modeling, because there are various applications and all the areas of branches of sciences and engineering, there is a modeling play very important role. So audience asking about good books about to start their career in mathematical modeling.
Yeah. For unfortunately for me, now, what I'm doing is very odd, and I don't have any book with me now. However, I will, through the MC, I will give you some references through this medium so that you can share with the audience. A few of them in my mind, but of course, there's a book that have been published in Discrete Dynamics System S by what you call Smith. Is Smith. The book has just been published. And I've gone through the preface of the book. It's one of the very good books that somebody who wants to go into model can start with. Of course, it's not free. You have to buy. You have to buy if they can buy. So I can share that reference with you later. It's one of the wonderful books I've seen recently, which they can start with. And it starts with the fundamental up to a certain point, the individual can go or be on his or own. And I also want to share again that you need experience modelers, so that through work, you share what you have, they share what you have, and you build yourself up. And I want to also emphasize that modeling also requires rigorous understanding of mathematics, especially dynamical systems. Must understand the mathematical system, must understand what we call how to construct global stability and local stability, Laplace functions, and some basic also theories in pure math must also be understood. For example, in fractional, we do use fixed point theory sometimes. Of course, we apply, but sometimes we also need some pure. So it's a collection of several disciplines, if you like, in mathematics. But for me, it's not difficult because once you have done engineering, you may not need analytical side. Once you're able to do a bit of coding, you can be engineer in civil, you can be engineer in maybe electrical, petrochemical, what have you. You should still be able to model once you understand your theory. That is the most important thing you should know. So I will make available some references. Unfortunately, I'm giving the presentation by a place where it's not academic place, not the house, not my house, not in my office, but fixed up somewhere, and I need to deliver this presentation and continue with what I want to do.
Okay, Professor, thank you for your very valuable talk. You present mathematical modeling and how we can establish the code and whole the process, how we can establish and how we can use the mathematical modeling and their part. And also you explained various type of applications in the engineering field as well as, and also I think the mathematical modeling is very useful these days to find out the solution of various type of problems around the world. And I hope your talk will be very beneficial for all the audience. And also I think that the audience will catch you after this talk, and many people or audience are contacting me how for your reference, and I hope you will provide all the books and the references for the audience so that the new scholars and scientists, mathematicians who are interested to use these mathematical modeling in their areas by using Matlab software. And also Matlab software also play very important role, and you explain by using this one. And I see that there are many type of coding part is there when you present the mathematical modeling using Caputo operator, fractional calculus is also there to study various type of applications. And thank you, Professor, for your valuable talk. And now I would ask from Dr. Upinder for the next proceeding. Please, Professor Upinder, yeah, she is there.
Thank you, sir, for such a wonderful session. And it was really a very experienced and knowledgeable session. And now I would like to invite Dr. Jayesh Sethi, sir, Assistant Director of International Studies of Baba Farid Group of Institutions, to give a vote of thanks and oblige all the members and participants.
Thank you, Dr. Upinder Kaur. I am here to present a vote of thanks for all the dignitaries, speakers who was there for delivering their talk today. Let me start out with Dr. Ibiziner Bonia. Thank you, sir. You came on. You was discussing the point all the way from Ghana. We are thankful to you for such a nice discussion on the topic. We had second speaker, Dr. Hamid. Dr. Hamid was from Iran, and he presented his presentation on Matlab today. Another speaker was Dr. Meher Chand. I'm thankful to him for making such a wonderful presentation. All the organizers of the team, Amrinder, Jaswinder, Dr. Upinder Kaur, Professor Manish Bansal, Dr. Manish Goyal, and all other who were there in the organization of this international webinar. I am thankful to him. All the participants who have participated from around the world, from many countries and many states of India, I'm thankful to all of you, those who have directly, indirectly helped in the organization of this webinar. Thank you. Thank you very much.
Thank you, sir, for your very thoughtful, provoking, and guidance. The entire session benefited from the breadth of knowledge and the depth of expertise. And I really grateful and thankful on the behalf of our entire institutes and all the participants and the panelists for giving your valuable time and help to make a webinar such a great success. Thank you, all of you. And I request all the participants to fulfill the feedback form at the end of the session. I request all the participants to kindly fulfill the feedback form at the end of the session. Thank you. Have a great day.
Okay.